a geometric series. So let's say S is the sum, and you start with A, right? A is the first term. You
Yeah.
add A times R, right? Which is ratio. And then you know what the next term would be?
AR squared,
Yeah, AR squared. What would the next term be?
AR cubed, and then
Yeah,
so on.
exactly. So on until your last term would be AR raised to the n minus 1 power, where n represents the number of terms you have. Do you know why it's n minus 1?
Because you're starting at 1 and not 0.
It's the idea that you start at 0, so that's why you had to take away 1, if that makes
Ah,
sense.
it was the other way around.
For example, if you have 3 terms, right? This one is 2, so the next one's 1 less than the number of terms you have.
Yeah, that makes sense.
So let's say that we multiplied the sum by r. If I multiply SR, if I multiply everything by r, that means that all of these terms will be multiplied by r as well, right?
Yeah.
I'd have to distribute the r into each of these terms if I multiply everything by r. So instead of a, I'd start at AR, then it'd be
Yeah.
AR squared. Eventually, I'd get to AR to the n minus 1. And then the last term would be a times r to the n power, right? Because
Yeah.
each term has one more factor of r in it.
Mhm.
Okay. What I can do is I could take these two equations and subtract them. So S minus SR. Do you know
Interesting.
what happens if I subtract the second equation from the first equation?
They would all cancel out except for like
Yeah,
A.
exactly. I aligned these up so they cancel out. What would remain then?
You'd have AR and ARN
Yeah,
or
exactly.
power
A,
N.
right. These cancel out. These subtract out. So I end up with A and then minus AR to the n power, right?
Yeah.
And then now notice that on the left side, there's S minus SR. There's two S's. I can reduce it by factoring, right?
Yeah.
So it'd be S times 1 minus R equals A minus AR to the n. Does that make sense?
Yeah.
Now I can solve, because remember, the goal is to come up with the formula for the sum, right? Which is
Yeah.
S.
Yeah.
If I solve for S, what would you get?
You would divide by 1 minus R, right?
Yeah, exactly.
It would be S equals A minus AR to the N over 1 minus R.
Yeah, exactly. So that's the formula for
Okay,
a
that makes more
geometric
sense.
series. Yeah. Okay, so now if you applied this formula in this problem, what would your A be? What would your R be?
A would be 40,000, and then AR be at least 40,000 times 1.03.
Well, do you know which variable 1.03 would be plugged in for?
That would be R.
Yeah. And what would your N be?
N would be, in this case, 16.
Yeah. So first year you get 40,000. Next year you get 3% increase, right? N equals 16. Okay, yeah. And if you plug these three numbers into the formula, 40,000, what would this term look like?
That would be 40,000 minus 40,000 times 1.03 to the power of 16. Then it'd be over 1 minus 1.03.
Yeah. If you do this calculation,
It'd be somewhere around 800,000.
yeah, something like this, 806,000.
Yeah, that looks
275.
about right.